Hello, my name is John. I am a virtual water engineer company Pakast Technical Services. In the previous series we discussed which well's diameter was suitable for us. In this part we are going to determine the flow rate of the water borehole and to talk about the dynamic level, static level and the height of the water column. What for should we know the flow rate of a borehole? First of all, it should be mentioned that calculating the volume of a borehole and its flow rate is not the same thing. Volume is an indicator of how much liquid a source can accommodate, and the calculation of the flow rate of a borehole is an indicator of the volume of liquid received in 1 hour, that is, the productivity of the source. It is measured in liters per second or cubic meters per hour. It is necessary to know the productivity of the borehole in order to determine whether the structure is capable of providing the need for water or the flow rate needs to be increased. After drilling, the operating company provides a test protocol or a certificate for the borehole in which all the necessary parameters are entered. However, it is difficult to calculate the productivity of the source accurately. The calculation of indicators takes time and special equipment. But, the result obtained will be sufficient to understand the capabilities of your borehole. Before proceeding with measurements, you need to comprehend what the static and dynamic water level in the borehole is, as well as the height of the water column in the borehole column. The measurement of these parameters is necessary not only for calculating the productivity of the well, but also for the correct choice of a pumping unit for the water supply system. Static level is the height of the water column in the absence of water intake. It depends on in situ pressure and it is installed after the downtime as a rule, at least an hour. Dynamic level is the steady-state water level during water intake, that is, when the inflow of liquid is equal to the outflow. Column height is the difference between the borehole depth and the static level. Dynamics and statics are measured in meters from the ground, and the height of the column from the bottom of the well. You can take measurements using a special tape measure, which signals when it comes into contact with water. Simplified debit calculation. Borehole flow rate is the ratio of the product of the pumping rate and the height of the water column to the difference between the dynamic and static water levels. In order to determine the flow rate of the borehole, the following formula is used, where dt, the required debit, V, the volume of pumped out liquid, Hdin, dynamic level, and St, static level, Hv, the height of the water column. To illustrate this, let's take a borehole of 60 meters deep, the static level of which is 40 meters, the dynamic level during G. The operation of the pump with a capacity of 3 cubic meters per hour is established at 47 meters. In total, the flow rate will be 8,57 cubic meters, hour. A simplified measurement method involves measuring the dynamic level when the pump is operating at the same power. This may be sufficient for the private sector, but not to determine the exact picture. Specific flow rate. The dynamic level and, accordingly, the actual flow rate decrease with the enhance in the pump performance. Consequently, the water borehole is more accurately characterized by the productivity index and specific flow rate. It is necessary to make not one, but two measurements of the dynamic level at different indicators of the intensity of water intake to calculate the latter. The specific flow rate of a well is the volume of water received when its level decreases for each meter. The formula defines it as the ratio of the difference between the larger and smaller values of the water intake intensity to the difference between the values of the fall in the water column. Returning to the conventional well, with a water intake of 3 cubic meters per hour, the difference between dynamics and statics was 7 meters. When remeasuring with a pump capacity of 6 cubic meters, hour, the difference was 15 meters. In total, the specific consumption will be 0,375 cubic meters an hour. Real debit. The calculation of it is based on the specific indicator in the distance from the Earth's surface to the upper point of the filtration zone, taking into account that the pump unit will not be flooded below. This calculation is as close to reality as possible. Where dt, borehole flow rate, hf, distance to the beginning of the filtering zone. In this case, we will take 57 meters, hst, static level, dsp, specific consumption. The total real production rate will be 6,375 cubic meters, hour. As you can see, in the case of our imaginary well, the difference between the simplified and the subsequent measurement is almost 2.2 cubic meters, hour in the direction of decreasing productivity. The borehole flow rate is calculated at the stage of determining the depth of the water pumping aquifer, drawing up the design of the well, choosing the type and brand of pumping equipment. At the end of drilling, the well is tested for productivity with the entry of indicators in the passport. If an unsatisfactory result is obtained during commissioning, it means that mistakes have been made in determining the location of the well, the target drilling depth or the choice of equipment. All things considered, when we talk about the well rate measurement, it is extremely important to highlight the static level of the water mark. To do this, you should not touch the water for at least an hour. It is during this time that a column of water equal to the static parameter will be collected. Then the well is emptied and the time for which the will be completely emptied is recorded. After that, they again wait until the well is filled, and measure again. If the indicators for several stages of water pumping are similar and correspond to the customer's daily consumption, then the drilling project is successful. The next fifth series will be devoted to the selection of pumping equipment.